Okay, so that's pretty much time, so let's get started. So, I love SQL, and I also really like running. And occasionally, these worlds collide, and I end up running a crazy route that looks a little bit like this. Okay, so SQL is doing weird things to my brain. It's causing me to run in the shape of SQL. But turns out SQL's also really useful for helping me analyze my training data. There's lots of questions you might have when you're going on an exercise program. Things like, are you sticking with your training schedule? Are you getting any better? Are you able to beat your personal best? That kind of thing. Turns out SQL is perfect for answering all these questions, and we'll see how to do that in this session. So I'm Chris Saxon. I'm part of Stephen Feuerstein's Oracle Developer Advocate team. It's my job to help you get the best out of Oracle Database and hopefully have a little bit of fun whilst doing so. Got the standard disclaimer before we begin, and a warning. This presentation contains something that strikes fear into all developers: regular expressions. Now, at this point, you might be saying, hang on a second, Chris, I thought this presentation was all about SQL. It's okay. There is going to be a lot of SQL in this talk. It's okay. We're going to keep it nice and easy on the regular expressions. Just a few things we need to know, just a few basics. So we'll recap them quickly. We need to know what these quantifiers are. So first up, we want to know if a variable exists 0 or more times. So we put the little star after it. Maybe we want to be sure something appears at least once in our data set, where we can use a little plus operator after it. Or maybe we want to know that something occurs a particular number of times or within a range of values. So we can use the little curly braces, say at least this many times or at most this many times. So it's okay, we'll recap all of these as we go through the talk, but these are key to really unlocking the power of the feature that we're going to discuss today. So let's get started. I did a lot of running when I was younger, and then I had some kids, and basically I did no training for quite some time. So last year, New Year's resolution, hearing the bongs of Big Ben ringing in 2018, I thought to myself, I want to get back into training. I want to start going and doing more running. So I set myself the lofty goal of going running every single day, right? Ambitious goal. So that's the first question we want to answer here. Have I actually done that? Have I run every single day? So here is a sample of my training data. And what I wanted to do is split it up into groups of consecutive days. I want to see first day in each group and how many days I actually ran consecutively. So we can see we've got 4 groups here, the first through the third, 6th and the 7th, and so on. So I want to split the data up into these groups. So how do we do it? Well, the first question we need to answer is, how do we know if rows are actually consecutive? How do we know if values are consecutive? Well, with numbers, we know that a little bit slow. Okay, a little bit slow. Okay, just do the above. Okay. How do we know if values are consecutive? Well, the current value equals the previous value plus 1. So that's how we know numbers are consecutive. Good thing about dates in Oracle Database, the unit of arithmetic is the day. So you add 1 to a date, you get the next day. So dates are consecutive if the gap between them is 1. So that's what we want to check here. We want to check if the current value equals the previous value plus 1. Now at this point, some of you may know this little handy function called lag, which you can use to look at previous values in your data set. And you go, okay, we're looking at the current value, and we need to compare it to the previous. Why don't we use lag? You can, but this gets messy very, very quickly. There is another technique you can use, and it involves a little bit of maths. So what we're going to do is add a row number to the data set. So just incrementing numbers, so consecutive numbers sorted by date. All right then, well, how is this helping us? Well, for dates that are consecutive, the gap between the date and the row number stays constant. There is a constant difference between those first 3 dates and those first 3 values. All right, how does this help us? Well, if we subtract the row number from the date, dates that are consecutive will all map to the same value, right? So we can see those first group all go through 31st of December, 2nd of January, and so on. All the rows that we want to group together now have the same value. How do we solve this? Well, we can just group those rows together. We can use a group by to figure out that they all fall together. This is the basis of something that is called the Tabular-Toasts method, okay? So that's the overview of how it works. How do we actually write the SQL to do it? Well, we need to add our consecutive row numbers to the data set. We can do that with the handy row number function, sorted by what we've called the order by, add an incrementing number to each row. We need to subtract that from the date, so we just take the run date and subtract it off. That gives us our group, those values, rows that have the same value. Finally, for each of these groups, I want to say what the first date in each group is and how many days there are. Well, we take the min and the count. Fairly straightforward. So this is a technique that's been around for quite some time that you can use to find consecutive values in your data set. There is, however, another technique which we introduced in Oracle Database 12c called pattern matching, which I wanted to introduce you to here. So what is the basis of pattern matching? Well, we're looking for pattern variables in our data set. These are values that rows have. And then we're looking for a sequence of those pattern variables in our data set. So we've got our variables and a sequence of those which form our pattern, which is where the lovely regular expressions come into this. So how does this work? Well, first thing we're going to do is define our pattern variable. So we're saying we know the first and the second are consecutive, because if we add one to the first, we get the second. We know the 7th and the 10th are not consecutive, because the gap between them is 3, or more generally, the gap between them is not equal to 1. So this is the pattern variable that we're looking for. We're looking for rows where the current date equals the previous date plus 1. So that's the basis of our pattern variable. We're going to put this in the define clause. So we've defined our variable consecutive. Next, we need to look for a pattern, a sequence of rows that contain this. So here's where our regular expressions are going to start coming into play. You might say, well, we want at least one of those, so we'll do like the plus operator. Not quite. We're going to have a pattern that looks like this. We've got start's a keyword, and consecutive star. I'll go, hang on, what's this start? What's this start thing? What's going on here? It's got no definition in the define clause. Well, you can put any variable you want in that pattern, and any that don't appear down here in the define clause are always true. So the first row we come to in the data set will match that start variable. And I go, well, why did we do that? Well, think about the first row in the data set. What value does previous have for that first row? Null, right? This saves us a bit of messiness and null checking when we get to an initial data set. So we've got our always true start, so we've already matched one variable. I will then find however many rows are after it that are consecutive. So I could have a group of consecutive runs of 1, right? It's not doing very well, but there could be any number of these. So we're looking for 0 or more instances. We have the star operator to do that. So in terms of how these pattern variables match to our data set, we'll just have a look and see. We've got our first, always true, matches the 1st of January. Second is consecutive with the first, second's consecutive with the third, so they get the consecutive pattern variable. Then we get to the 6th of January. The difference between the 6th and the 3rd is not 1, so we've ended that first group, and we start a new group, which again goes back to our start pattern variable. And we repeat the process, keep going through our data until we've traversed the whole thing. Okay, so this is great. We've defined what we're looking for in the pattern, but I've missed a step here. I've said we've got this previous. But I haven't actually really defined what previous means, right? How do we know what it is? So hopefully, you know, if you write your standard SQL query, if you've not got an order by on it, well, the rows can come back in any order. They can come back in any sequence. It's the same with match recognize, pattern matching. You need to define an order, the sort that you're going to walk through your data set. So you can do that with an order by clause. Nice and obvious. Do note, this is a technically optional clause, as in your query won't throw an exception if you exclude it, but if you do exclude it, it's almost always going to be a bug, right? It's almost always going to be a bug in your code. You want to define which way you're walking through your data set. So make sure you include an order by. You're not going to get a warning that it's missing. So we've defined what we're looking for, how we're walking through our data. Final thing I want to do is add those two values to my output data set, right? I want to say what the first value is in each group and how many there were. And we can do that with our measures clause. So this completes off our match recognize clause. We're saying we want the first run, get the value from the first row in each group. So that is going to be the one that matches that start variable. And then we want how many there are, which is just the old count star function that we all know and love. Easy, right? Too much for after lunch? Yeah, okay, all right. Okay, so we do that, we get the data set, and we can see, I'm not really sticking with my running every single day here, am I? Most I'm really managing is 3. Okay, I might need to rethink this a bit. But we've got 2 techniques here to solve this find consecutive rows. And whenever you've got 2 ways to do one thing, people always get a bit apprehensive and go, which is the correct approach, which is the right way to do it? And the short answer is it's kind of down to you. But let's just recap some of the differences briefly. First up is down to when they are available. So pattern matching only became available in Oracle Database 12c. Anyone here using Oracle Database 11.2 or older versions? A few of you. So you're going to have to use the Tabular Toasts approach. Okay, so we've got, assuming you are on 12c and you're able to actually use this feature, you might go, okay, well, which do we use? The next thing a lot of people get really worked up about is performance. Which of these is going to be faster? And again, the short answer here is they're pretty much the same. They come up very similar. Obviously, if you really, really care about performance, test both on your data set, see which comes out faster. But there is no real solid advantage to one over the other to give a general recommendation. So the final thing is, just which do you find easier to work with, which do you prefer looking at? That's kind of a personal preference of which you think is the better approach here. That all said, I would say pattern matching is the right way, or my preferred way, to use this if you're working from 12c. Why? Well, it becomes much easier to adapt to changing requirements. So as we saw, I really wasn't sticking with this running every single day plan, was I? There's research which says setting yourself an unrealistic goal, which you're never going to achieve, is just kind of demotivating. Even back when I was running half marathons, I don't think I ever ran more than 3 days consecutively. So I want to reset a bit. I want to set myself a more realistic, still a stretch goal, but something I'm actually likely to be able to actually do. So rather than run every single day, I'm setting myself the goal of running at least 3 times within a given week. So how can we do this? Well, one way to approach it is say, do runs fall in the same calendar week, Monday through to Sunday? So the question we need to answer there is, how do we know if 2 dates fall in the same calendar week? Now, there's various techniques you can use to answer this. What I'm going to use here is say, is the Monday for the current row the most recent Monday equal to the most recent Monday for the previous row? So today's Tuesday, the most recent Monday is yesterday. If today was Monday, the most recent Monday would be today. We're checking whether 2 dates fall in that same Monday to Sunday calendar week. Okay, well, how do we do this? How can we see if 2 dates are within the same calendar week? Now, you may be familiar with a trunc function, which you can use to strip the time component off the date. What you may not know is it also supports a whole bunch of date formats, one of which is this lovely little IW format. We do that, pass a date into it, and it returns the start of the ISO week for that date, which just so happens to be a Monday. Awesome, handy, right? So we can add this to our data set. So we put that trunc function in, and we can now see all the dates that fall in the same calendar week all have the same value. So we've got 3 groups here, 1st through the 7th, 8th through the 14th, and so on. So now we've got rows which have the same value. How do we bung them together? Well, we just use a group by. So we group by that expression, and all runs that fall in the same calendar week get grouped together. I wanted to only return those weeks that had at least 3 runs in them. How do we do that? What do we need to add? Whoa, come on. Feeling a bit slow today. It's like, having clause. Thank you. Someone, there we go. So we need to add a having clause. Say, we only want those weeks where I ran at least 3 times. So this is pretty standard SQL, fairly basic. How would we solve the same problem using SQL pattern matching? Well, let's review. What are we looking for? What are we looking for here? What is our pattern variable? We're asking, is the date, the most recent Monday for the current row, equal to the most recent Monday for the previous row? If they are, then they fall in that same calendar week. So this is our pattern variable. Compare the most recent Mondays for those rows. So this is going to go in our define clause. So here, we now got a pattern of start, same week star. So this will return as weeks I ran at least once. I don't want that. I want weeks I ran at least 3 times. we've already got one row from our always true start. I need another 2. So we do the lovely little curly braces, at least 2 or more instances of this. So now I can find all the rows where I've run, all the weeks I've run at least 3 times by finishing off the query. Now at this point, some of you might be going, hang on a second, Chris. This is a bit messy, right? We had that previous group by query, which is just basic, fairly standard SQL. Why would I ever write this as opposed to that group by statement, right? Well, let's compare this approach, 3 weeks I've run at least 3 times, to the consecutive rows approaches using match recognize. Let's just flick backwards and forwards a couple of times. What's changing? Basically nothing. I've changed the definition of the pattern variable, fairly obviously. I've renamed the variables for clarity as much as anything else, and we've had to change the quantifier from 2 to star. Imagine you've had that change in requirements. Find me all the consecutive days, and then someone goes, oh, hang on, we don't want that. Find the weeks we ran at least 3 times. We only have to tweak the SQL statement slightly. Whereas we went from Tabibito San to group by, well, you're basically throwing your whole query away and starting again, right? So imagine this is actually part of a much larger SQL statement. It's easier to adapt this to changing requirements. Now, at this point, some of you might still not be convinced and kind of go, well, hang on, I'll just stick with group by, right? I know that, I know it's easy, we'll stick with that. Well, let's kick things up a notch. Let's change the requirements again. So I travel quite a bit doing this job. So here's a sample of my calendar from towards the end of the last year. All those dates marked in purple are days I'm either traveling to, at, or traveling home from a conference. And I can tell you, during those times marked in purple, the only type of running I do is sprinting across the airport trying to catch a plane, right? The 4 years I've been doing this job, I have never gone on like a scheduled training run. So rather than look for calendar weeks, I'm going to have these times where I'm just not going to do any running. So rather than say, did I run 3 times within a calendar week, I want to say, did I run at least 3 times within a 7-day period? Okay, so if we look at my calendar here, let's say I go running on the 12th and I run 3 times that week, I've hit my goal. If we then start counting from the 19th, well, I'm at DOAG in Nuremberg for 5 days. That leaves me 2 days to go running 3 times. The chances of that happening are 0, right? So I don't want to penalize myself. I want to reset the next 7-day counter from that Saturday the 24th, and run through the next 7 days. The key point here is there can be any gap between the end of one group and the start of the next. So if we split my data set up, we've got 2 groups here, the 1st through the 7th and the 10th through the 15th. If you try and split this using calendar weeks, this second group spans 2 calendar weeks. And however you do this, eventually you're going to run into this problem, right? I don't want to do that. I want this next counter to start on the 10th and run through to the 16th. Are those all in the same 7-day period? So how do we test for this? What are we checking here? Well, we're saying, is the value for the current row, the date of the current row, less than the date of the first row in the group plus 7? If it is, it's within 7 days. They form part of that within 7 group. OK, so how do we do this? How do we do this with traditional SQL? This is where things get a little bit messy. OK, so if you are on 11.2, you can go with recursive with. I'm just going to show these on the slides very quickly just to kind of scare you. I'm not going to walk through them. If you want to know more, just come and talk to me later. So there we go. Oh, God, that's horrible, isn't it? Right, let's get rid of that. Not an 11.2, really old versions of Oracle Database. You're lucky. You get to play with the model calls. Again, let's just put that on the slide just to scare ourselves about how horrible that is. Let's move on. So those are pretty nasty. They're very gnarly queries, not easy to understand what's going on there. How does this work with pattern matching? Well, what are we looking for? We're saying, is the date of the current row less than the date of the first row in the group plus 7? This is the definition of our pattern variable. That goes in our define clause. What's the pattern we're looking for here? Well, I want at least 3 instances of this. So in this case, I do a pattern of within 7, 3 or more. And you might go, hang on, didn't I have like that start variable, the start always true variable? Why don't I have that now? Well, first row in the data set, we are saying, is the date less than the first row plus 7? Is something less than itself plus 7? Well, duh, right? You know, that's always true. We've defined this pattern variable, so it's already always true for the first row we get to the data set. So you may not need that always true start. So we do that, we get our within 7, finish off the query, and we get some output that looks a bit like this. Now at this point, some of you might go, well, okay, this is neat, helping me analyze my running data. Why would you really want to do this? Well, think something like sessionization for activity for your application. You want to group user activity into blocks of 1 hour. So I start using your application at 12 p.m. You want to group all activity up to just before 1 p.m. That's one session. We then want to group together my next activity after it. I am very, very unlikely to use your application at exactly 1 p.m., right? It's more likely to be a few minutes past. Maybe I've gone to lunch, and I'm not going to use your application at all until 1:30, 1:45 or something like that. If we start the counter again from 1 p.m., there's like this big block of time where I'm not even at my desk, right? We want to start that next session from the time I next use the application. So we can go from 1:45 through to 2:45, something like that. Questions, comments? Too much for after lunch? Okay, so we can see whether or not I'm sticking with my training schedule. Next thing I might want to ask about when you're doing some exercises, are you improving, right? Is this actually doing you any better? With running, that's really easy to analyze. You just say, am I getting faster? Is the time taken to complete a run less? If it is, I'm getting faster and I'm getting better. Brilliant. So what I want to do is tag each row in my data set and say whether or not it was faster or slower than the previous one. So what are we looking for here? The variable we're looking for here is, if it's faster, the time taken to complete the run is less. Is the current time less than the previous time? If it is, then it's faster. And I want to tag it like that. So that goes in the define clause. I've called it faster. And the pattern I want is 1 slower followed by any number of faster. So our initial one marked as slower. It's not strictly true, but it's good enough for my purposes. And then the next one, hopefully, I'm getting faster and faster and faster. I have a nice big chain where I have like 100 runs and I just keep getting faster and faster and faster. That's probably not going to happen in practice, right? I'll probably have a few where I get slower. Hopefully, I'm not going to get slower and slower and slower. Okay, so I've named these faster and slower. A couple of reasons. One is it just helps make the statement a bit more readable, makes it clearer what's actually going on. But we can also expose these pattern variables in the output, in the measures clause. So we say, use this classifier, and that will return the name of the pattern variable that row matched. Okay, so now we can see whether each run was faster or slower. So we do that, we'll run the query, and we'll get something that looks like this. This isn't really what I wanted, right? I wanted every single day, along with whether or not it was faster or slower than the previous. So what's going on here, and what can we do about it? Well, by default, match recognizes an implicit clause of 1 row per match. So this works a little bit like group by. Group together all the rows that match it into 1. So I have a chain of like 10 runs where I keep getting faster. They get collapsed into 1 in the output. And the classifier variable returns the value for the last in that group. So that's not what I want. I wanted every single row. So what can we do about this? Well, we can change this to all rows per match. So this preserves the data set. We do it, and now we can see whether or not I'm faster or slower. So we can see which pattern variable it matched. Great. Maybe. There's still a problem here. Let's look at these 2 runs. I've got a 5K run followed by a 1K run. Unsurprisingly, I have marked that as faster. You know, that just kind of falls into like the well-duh category, right? I can walk 1K faster than I can run 5K. So that hasn't really told me anything. But the problem gets a bit more interesting when we look at these 2 1K runs down at the bottom. I've tagged this one as the 14th as faster. But actually, if we compare it to the previous 1K run, it is in fact like 15 seconds slower. I don't really want to mark it as faster. So how can we do this? Now you might say, why don't I compare my average pace with my average speed? I could, but I know the further I run, the slower I get. You know, my average pace for a 5K run is 5 to 10% slower than my average pace for a 1K run. So it's a bit better, but it's not perfect. What I want to do instead is compare 1K runs against each other, 5K runs against each other, 11K runs against each other, and so on. So really, I want to carve up my data set like this. Now in this instance, I could just sort by distance and then by date, and put that in my order by. But again, that's not strictly speaking correct. What I actually want to do is only compare 1K runs against other 1K runs, only compare 5K runs against other 5K runs, and so on. So how do we do this? Well, we can use the partition by clause. So this carves your data set up into groups, and only rows which have the same value for distance in kilometer will get compared against each other. So if you're familiar with analytic functions, it's the same kind of principle, same idea, does like that. So we do that, add that, and now we can see we've got everything there, and I'm correctly tagging that run on the 14th as slower because it was slower than the previous 1K run. Questions, comments? No? OK, let's keep going. So we've seen whether or not I'm actually sticking with my training program. We've seen whether or not I'm improving. I also set myself a goal. So I entered a 10K race towards the end of last year, and I set myself the target of running it in under 50 minutes. So what I want to do is kind of do a little bit of predictive prediction and say, based on my training data, am I actually likely to achieve this, right? So in order to run 10K in less than 50 minutes, my average pace needs to be under 5 minutes a kilometer. So that's what I want to look for. Is my average pace less than 5 minutes a kilometer? What I want to do is group together runs up to a total distance of 10K. So I can say, add them up until we get to distance of 10. Is the average pace across that 5K? How is that speed? Now, it's not ideal, but it's really just to give me a finger in the air, right? If this comes out at like 6 minutes a kilometer average pace, I know I'm stuffed, right? I don't have a hope of doing this. If it comes out at 4 minutes a kilometer, I'm golden. I'm going to ace it. If it's like 4.5 minutes to 5 minutes something average pace per kilometer, maybe I can do it, but I probably need to up my training a bit, right? So based on how I'm going, am I likely to do this? So what I want to do is say, find my average pace, we'll move it to seconds, that's what we've been using so far. Is that under 300 seconds a kilometer for runs that sum up to a distance of up to 10K? So what are we doing here? Well, the pattern variable here is in this runs with a total distance of 10K. We want to group those together. We want to get rows where the cumulative distance is less than 10, and they all fall in the same group. So cumulative distance, we're adding things up. What function do we have to add things up in SQL? Come on, you must be feeling strain after lunch. Sum, add all these rows together, add all the values together. So this gives us the running total. We're adding them up until the total distance is less than 10. So this sum is that running total. So that first row was 1K, a running total is 1. The next one, 5K, a running total is 6. And we'll keep going until that gets more than 10, at which point we start a new group. Okay, so that's the definition here, and we want many of those. At least one, there could be many. We'll finish the query off, and we'll get something that looks like this. So a couple of things. First up, my average pace is around 5 minutes a kilometer. Probably need to improve things. But there's a problem. I'm missing my 11K run, right? I've summed up runs up to a total distance of 10. Anything that is over 10 is going to be excluded from my results set. This is going to give me an overly optimistic picture of how I'm actually going to do on the day, right? The further I run, the slower I get. I'd like to also include really long runs, so I'm kind of balancing things, my 1Ks out with my really slow 11Ks. So I need to tweak what we're looking for slightly. I want to find any number of runs up to a total of 10, and then exactly one which takes me over 10. So we had our 1, our 5, which took us to 6. Then we add on our 11, which takes the total up to 17. We are now over 10K in total, and we'll start a new group. So here, we've got a pattern, 0 or more instances of under 10K, followed by exactly 1, that is over 10K. So we need our 2 pattern variables here. Now notice, they both have sum here. They are still the overall running total. They are not considered independently. We start the order they appear in the pattern, so we keep summing up under 10K until, as long as that total is under 10K, and then we check if it's over 10K. So these are the overall running total determined by which order they appear in the pattern. We'll finish the query off, and we'll get something like this. OK, so I'm no longer getting the overly optimistic rosy picture where I'm only including my short runs, but there's still a problem here. I would kind of like to see any runs which are like in the 9 to 11K split out on their own, right? They're going to give me the best idea of how I'm actually likely to do when running a 10K race. So any runs on 9 to 11K, I want to see on a line on their own. Also, I'd like to get more of a kind of rolling average. So here, we've compared the first 3 runs, got that total, then moved to the next one. I want to do this for every row in my data set. So I want to start with the first, and then do the same for the second, and so on. So how can we solve this, and what's going on? How can we fix this? Well, again, there is another implicit clause with match recognize, this after match. It says, after match, skip past the last row. So what that means, by default, we sum up runs until we get to our total over 10. We then go to the next row in the data set. Those first ones we've visited, we just forget them. What I want to do instead is change this to after match, skip to the next row. So we get to my total over 10. I then go back to the second row in the data set, the second in January, repeat the process. Then go back to the one on the 3rd of January, repeat the process. Go back to the 4th row in the data set, repeat the process. The key thing here is we're going to be revisiting rows many times, potentially. So we do that, we split the runs out, and we get something like this. So now I can see that 11K run nicely split out on its own. And I'm looking at this and I'm thinking, 325 seconds, nearly 5.5 minutes a kilometer to run 11K. That's not looking good, right? I'm gonna have to up my training to meet my goal here. So I did this analysis and kind of said, well, I need to put more training in, put a bit more effort in. And then towards September last year, came through, ran it in 48 minutes. Yay, fantastic. So the power of SQL helped me figure out whether or not I needed to improve my training. Okay. You might go, okay, it's helping me do some analysis here. What is the real world use case for this? Well, this is a form of bin packing type problem. Think things like you are trying to load goods onto containers. Each container has a maximum weight limit. You need to keep adding things up until you hit that limit of 1,000 kilos or whatever it is, at which point you need to start loading things into the next container. So, very simple way to help you solve these bin packing style problems. Any questions, comments? Still processing, right? Still thinking? Okay. While we're mentioning performance, let's also talk about query performance very briefly. So people are going to go, we've got this match recognize clause, surely it's going to add some overhead. How is this actually going to perform? So first thing to be aware of here is your table or your query is the input to match recognize. So the first thing you need to do is run your query without match recognize. If that takes 10 minutes to run, then it's going to take at least 10 minutes to run with pattern matching, okay? So bear that in mind. Check how long it takes to run the query without using all this match recognize stuff. But what about match recognize itself? What overhead does that have? Well, there's something you need to look for here in the execution plan. So if you're using it, you'll see a line that looks something like this in your execution plan, match recognize sort. And if that's all you see, what that means is it's a non-deterministic processing of that regular expression. I'm not going to go into details, but basically what this means is it can get really stuck into backtracking. If that is all you see, your SQL could end up being really slow. And this relates to the regular expression processing. It's nothing to do with SQL itself. So, we go, oh, it's slow. That's horrible, right? Why would we use this? Well, there is a nice happy place. If you see these words after it, deterministic finite auto, that means we are guaranteed the regular expressions written in a way that we're only going to process each row once. We're not going to get trapped in backtracking hell. So this is the words you want to look for in your execution plan and assess how likely match recognize is to actually perform. Okay, so we've seen whether or not I can stick with my training program, whether or not I'm improving, whether or not I'm actually likely to achieve some kind of goal. Let's do something a little bit wacky to finish up, okay? I want to look for a bit of a weird pattern in my data. I want to say, how often did I go on a 5K run, followed by 2 or more 1K runs, all within 7 days, okay? All right, so how do we do this? So my pattern here is 5K followed by 2 or more 1K, so that's the pattern. What is the definition of these pattern variables? Well, 5K, we're just saying the distance equals 5. We don't have to use any of that fancy previous or sums and so on. You can just look at values in the columns. So that's our 5K. How do we define our 1K? Well, we're looking for rows where the distance equals, come on, 1K, distance equals 1, okay? However, these both need to fall within 7 days of that. How do we test for that? Who can think back 15, 20 minutes? We want to say that these values are within 7 days of that first one. That's that criteria we were testing earlier. So we do that, we'll finish off the query, and we'll get something that looks like this. We'll see it's happened twice in this data set here. OK, where the heck would you want to do that, right? You know, I'm a data geek, and I like analyzing my training data. Maybe I'm following some really prescriptive training program or something. But what's the real-world reason for doing this? Well, this also relates to a key use case match-recognized pattern matching was developed for, investigating fraud. So let's say you want to analyze transactions between two accounts, and you're looking for a situation where you've got 2 or 3 small transactions, let's say €1, from one account to another, and then within 7 days, maybe a month, there is a really large transaction, like say more than €10,000. That's weird, right? You know, if you've got repeated transactions between accounts, they're usually a similar amount. Things like maybe your credit card bill, your gas bill, they fall within a similar amount. You don't have this lots of small transactions followed by a huge one. So that's a sign that something fishy is going on, and you probably want to look into it a bit more detail. Pattern matching helps you analyze and solve these really easily. And actually, this is the kind of use case where pattern matching really shines. It's where you're looking for a sequence of events that happen across rows, probably within a given time frame. Think things like customer retention analysis. You want to find all the customers who are really loyal, but recently have left you. You know, you want to find everyone who placed at least 2 orders a month for 6 months, maybe a year, but in the past 6 months, they placed 2 orders total, right? You want to find them so marketing can send them offers or promotions or something like that. Or things like workflow analysis. You probably all experienced the project where it's like, it starts, it goes into analysis, you start doing some development in, maybe it gets to actual doing testing, and then it goes all the way back to being an analysis, and you start doing some work on again, and then someone goes, oh no, we've changed our mind, we go back and do some analysis, and you keep getting stuck in this cycle of it getting put on hold, started again, put on hold. So you've got a sequence of events that these rows have gone through, probably within a series of time. So this is where you're saying, different rows have different values, probably time-bounded. How are we looking for those in our data set? These are the kind of queries which typically you'd solve by like nesting analytic functions on subqueries on subqueries on subqueries, or joining the same table to itself like over and over and over again. That is a sign that probably pattern matching is what you should be doing instead. So this is the real sweet spot in my opinion. So this is a really powerful feature. And with great power comes the ability to get yourself completely and utterly stuck, right? You know, so this is really cool, but you're going to get unstuck at some point, or completely stuck. So how do you debug it? How do you understand what's actually going on here? So the first thing to remember, the real power of this comes from regular expressions. Regular expressions are so easy to get wrong. You know, if you think you've understood a regular expression, you probably just haven't thought about it long enough, right? So that's the first thing. Think very carefully about your regular expressions. A site I really like to use to help me understand what's going on is regex 101. You can put your regular expression at the top. Unfortunately, because of the way pattern matching works and it's row data, you can't just dump your data in here and it will figure it out. But up on the top right there, it gives you an explanation of why it forms which groups. So it's good to help give you an idea of what regular expression is going on. So first thing, keep your regular expression simple as you can. Validate you've got it right. Next thing is there's some extra information you can add to your result set to help you debug it, help figure out what's going on. So we've already seen the classifier function. Very useful if a row could match more than one pattern variable. Which one did it actually match? We'll tag that in the result set. The other thing is, which group did it fall in? So we can use match number. So we group together our first batch of consecutive runs, that's group 1. Then we add our next batch, that's group 2, group 3, and so on. So again, a row could fall in more than one group, potentially. Finally, as I said, by default, match recognize works a bit like group by, in that all the rows matching a pattern get collapsed into one. So if we've got a big chain of 10 rows, we've just got 1 in the output. So we set that to all rows per match. However, it only returns rows which match the complete pattern. If somehow you stuff up your pattern completely, so it matches nothing, you'll still get no rows in your output, right? So you also want to add this with unmatched rows. That will show you all the rows from your input. So your table is the input to match recognize. So all rows per match with unmatched rows preserves that input data set, makes it much easier to see what's going on. So we do that to my previous query, like the 5K followed by two 1Ks, and we get something like this. So we can see we've got our two groups at the bottom with those variables matched. Now you might note, on the 2nd of January, I ran 5K, but it doesn't match that 5K pattern variable, or it's not got that set. Why not? You have to match the complete pattern, okay? So it has to be a 5K followed by two 1Ks. If somehow, somewhere in the chain, it's gone wrong, it's not going to appear here. So another thing, if ultimately your pattern's going to have like 5 or 6 variables in it, try and build it up incrementally. Start with one, add the second, and find out which point in the chain it breaks. Okay. Any questions, last questions or comments before we wrap up? Yeah, question over there? Any rival products? Sorry, I'm struggling to hear you.
Are there any rival types that one should not apply pattern matching to, like, so for example, you apply pattern matching to date types?
Oh, any data types which don't apply to pattern matching? It's a good question. I don't know off the top of my head exactly. I can't think of clobs, maybe not. But thing is, we just pop back briefly here. Whoop, there we go. So in here, this is kind of standard SQL. So any standard, doesn't support everything, doesn't support all the aggregate functions, but any function like, so if you've got the dbms lob functions, you can call those in there. Does it support clobs directly? Not sure, I'd have to check that. But you can manipulate it to get it to be a shorter string. Any last questions or comments before we wrap up? Seem useful? Yeah, not sure. Seem complicated? Yeah. So, I hope I've given you some idea of the kind of things that you can solve with this. So, I think this is a great feature. And I think it helps solve a lot of problems which are pretty tricky to solve using standard SQL. So you know you're addicted to running when you get to the end of the race and first thing you think is, I'm going to enter the next one, right? You go, oh, I've got to straight in, going to enter the next 10K. You know you're addicted to SQL when you come to a presentation about SQL and you think, I've got to know more about that. I've got to learn and figure out how to understand and actually use this. So what resources do we have to help you learn pattern matching? Well, there's quite a few available. So on Live SQL, Gerald was mentioning this morning, we've got a whole stack of scripts and tutorials already built in here. So these are kind of step-by-step examples you can walk through. So if you've got lost anywhere in this, which I'm sure you have, take a look at these, step through them, and figure out what's going on. So these were written by Keith Laker, who's the product manager for pattern matching. He has also written an ebook. So he's got the complete guide to pattern matching, okay? That covers pretty much everything I've talked about today, plus a little bit more. It's volume 1, right? He's planning a second volume. This is a really, really big feature. So there is a lot more to it. There is a lot of power. And it makes it really easy to solve a lot of problems which are somewhere between effectively, just awkward and effectively impossible to solve using standard SQL. I think this is the best thing to happen to SQL this century. So I really urge you to go out there, investigate SQL pattern matching, look at use cases, look for situations where you're looking for a sequence of events that happen across rows. So all that's left to say is, I really hope you enjoyed this. More importantly, I hope you learned something. I'm Chris Saxon. It's great to be here in Berlin. Enjoy the rest of the day.